Alright, hi everyone. Welcome back to this series of making a programming language in Zig. So I've done quite a lot. I'll probably forget all the stuff I've done. I'll just go over to the checklist. So yeah, we still haven't done any checking really, because that's probably the hard part. But what we have done is we've done floats, we've done char, we've got basically all the basic types working. We've got arrays working. We haven't really got lists working. So in theory we could do that. But I just haven't yet. I mean, basically, the way I have arrays is they work like slices because we're converting to Go for now. They work like slices anyway. The only thing that really won't work is like append and things like that. But in theory, I could just write append and it will convert directly over. I just, would prefer to make my own syntax. But that's the only thing. Otherwise, it just works, basically. Lists are arrays. I might, it's just for simplicity. I might make it different later. But anyway. Globals I probably should do, and casting I haven't done, but everything else basically works for Go anyway. Then, some things were kind of weird. For example, things like let's say structs. So I'll show you structs. So for example, we have So I have a few other things as well, but I'll go for that in a minute. For now, we're going to make sure, we're outputting not to file. So we're going to come here to print output, and we're going to put in, let's say, struct sample struct1, and then we're going to run this. Alright, so yeah, that basically is so the input code we're not showing, so I'm just going to show the input code. Okay, show input code is true, and then run that again. So we're putting in, so basically the syntax is not being shown. There we go. Syntax here is just struct person, int age, string name, and then just semicolons, and then that's all. That's all we're doing, and then it converts this to Go. This will obviously give us an error because we're not using FMT, but anyway, Go can, Go do one. But anyway, that's how structs work. They're pretty simple. We don't have methods working, but I can do that in the future. I can't be bothered at the moment. So I'll just show you some other code I have. So struct2, I don't remember what this does, but let's see what this does. Alright, so this one, it's basically just creating a person, set the age, set that, and then print it. That's all we're doing. And that converts to Go pretty normally. Doesn't really, this works fine really. I'll show you the ASTs. So let's print AST nodes, true. Alright, here are the AST nodes, and for some reason the code is coming after that. Should probably fix that. Anyway, it doesn't matter. Struct declaration, because I changed a few things. Obviously, the AST is going to be different now. So struct declaration, the base node, you have the struct members, which is on the right, and then they have children, are the members, and basically you have the var type and the name. You have the name of it, and then the type here, and they nest. Then the function declaration, we have a struct member access. So basically they're nested. So you have the struct member access person, and then it'll put a dot. And then it will basically print out age and then equals 20. So it's all nested like that. That's how it works. And it wasn't actually too difficult to actually do this. I'll show you some of the code. For example, in I think it was in convert. I don't remember exactly where it was. But if we go to convert body and process body, here we have process struct member access. So basically, if you find a struct member access, like here, you find a struct member access, you call this function here, it basically just prints it out with a dot, prints whatever the token is as a dot, and then calls this function again. So it's kind of recursive. So this calls this function, that calls the struct member access, and the struct member access calls process function body node again. So it's basically like we find this, we print that, put a dot after it, and then we sort whatever this is afterwards, and it just works recursively like that. And yeah, it works fine. With enums, so the problem with enums is Go doesn't have enums. Go pretends to have enums, but they really don't have enums. They suck. There's this ridiculous iota kind of workaround, which is really stupid and is terrible. So I decided to make I did what I did in TypeGo. I basically made them structs, and made them integers inside structs. So I'll show you that. I think I have, yeah, enum, and then enum1. But basically, we get from this enum employee type admin regular intern, just regular enum. It creates it into this, which is basically the same as struct, really. Right, and then on the child, and then all that. And I don't have setting the values, because in theory you could set the values. So if I go to this, you could do something like, equals 0, whatever. I haven't done that yet. It's not that hard to implement. I just can't be bothered. That will be in the future. That will basically just set but basically it converts it to a struct, which is what you should do anyway. It's what Go should do. You could do it yourself if you wanted to. Just have some integers inside a struct, and then it's namespaced. But apparently Go doesn't want to do that because they're weird. And then you have this employee to string, so you can print it. And that's basically, so I mean, all you need to write is this, and then it generates all this code for you. I mean, that's what all Go really needs to do, but it's taken them like over 10 years and they still haven't done it because they're weird. Anyway, it takes a random programmer to fix Go. Right, anyway, do I have another? Yeah, I'll show you enum2. Whatever enum2 does. Yeah, I think this just uses it. So, I mean, one problem is you can't set it to an employee type. You have to set it to an integer. That's the only real downside to this. But it's a workaround. Maybe in the future I could do it. But for now it works fine, just to make it integer. Because that's what they are they're integers anyway. So integer employee.admin. So it works. It's namespaced. It's not global constants like Go is, because Go is stupidly designed. And then we have this string here just because I don't want to put it... I don't like putting loads of stuff in print line. So I just have employee text, type text, and then print it. So if you want to print it, you basically type in employee type toString, and then put in whatever you want, and it will convert it to a string for you. You do have to use that. That's one downside. In theory, what I would like as syntax would be something like, say you have here employee type. We have this. And then that should, in the background, convert that to an integer, I guess. But you'd have to track it, which I haven't tracked it yet, which is another whole can of worms that I can't be bothered to do. But anyway, so say, for example, you wanted to convert it to string. The simplest syntax I would prefer would be something like this. Say string employee type as text, whatever, I don't know. Equals employee type dot, well, how would you be able to toString, like that. That would be the better syntax, I think. But anyway, that takes a lot of work, because I have to recognize that this is an enum type and then this is toString, and then convert it over to employee type toString and call the function. It's a lot of work. It's easier just to do this and not go insane. Just do this toString employee type. That's just easier for now, because then it just converts directly over to actually how it works in Go. Anyway, that's how enums work. So they're namespaced and they are not global, because that's stupid, and you can print them. Anyway, so yeah, and another thing I did was I added a way to print to file. Because obviously you know, if you have a programming language, you want to be able to run it in the console. I'll just show you that working for now. So here I have, I go to zig out, bin, and we have this here. So we have main.cm. So the language name is called C-, which is kind of a joke, because it's kind of like C, but with less features. It's not C++, it's C-, it's less features. It's kind of a joke. So anyway, we have the extension .cm. Anyway, so if you want to run this, it's not on the path, because I can't be bothered to put it on the path. So basically what we're going to need to do is we run this, we go // and the name of the exe, and then you can put the arguments in. You put the arguments in, and then it runs the code, whatever main.cm has in it. We actually have this not set up right now. 1 second. Because we've ran it with this, let me just wait. Every time we run it, it actually outputs this file. That's kind of the problem. Okay, show input code. We want this to be false. Output to file we want to be true. Show AST node we want to be false. and then we can run it again. Yeah, it will give you errors, but I don't care. As long as it outputs the file. And then I can run this again. Okay, there we go, it runs. So whatever we had in it, so in the main.cm we have this weird, we just have this calculating temperature program. So it just tests enums, of course it tests functions. For some reason, I don't know why, but when I put a bracket first, it gives you an error, so I have to fix that later. Because in theory, what you should do is just do return, or return Celsius, like this. It should be that, without the temp. But I just put the temp there as a workaround because brackets gave me an error and I couldn't be bothered to fix it. I'll do it later. So I basically have this temp1, just, you know, just so I don't have to put a bracket there. Everything else works, and that was the output. So we put in as the we're basically putting in Celsius to Fahrenheit in integer, which is actually the enum, and we went 100 and 0, 100 and 0. We want to convert from Celsius to Fahrenheit, Fahrenheit to Celsius, and show the results. We're not using floats, we're using integers, but anyway, that's what we get as a result. So we can just literally just run whatever we want in the console. So I could change this if I want. I could delete this, do, you know, print line, say hello world, go like this, and we have a hello world program. You know, this basically just runs as like it would. Because it basically, I'll show you the code. So I didn't really write this, to be honest, because I don't know how you do this in Zig. I got an LLM to generate for me. Because, okay, first you have to get the args, and I don't really like inferred types, but to try and do this, I don't even know what even is that. Could I copy this? This is, I don't even know what that is, to be honest. It's a slice of U8. Okay. Whatever. So we get the args and we have to allocate to get the args for some reason. I'm guessing, not sure why. And then we defer and get rid of it at the end, which I don't think we need because we're using an arena allocator, but I'm going to do it anyway. Then we get the arg length. We make sure it's run. I don't know if we need this really, but basically this is just, did you write run or not? If it doesn't, then you say the usage and say that and then return. Obviously args need to be 3 as well because we need what usage cm run but in this situation we don't actually need cm. That's just if you put it on the path you'll need cm, but now we're just calling the function anyway. Then the source file, which should be this. We get the source file, which is a U8 slice. We read the file source because we need to obviously convert that into Go. We get the file source, we free that. Then we go code. Yeah, they generate the code, and we basically I changed convert code to return a string. Well, a string is basically just a const U8 slice. I just couldn't be bothered to keep writing that all the time, so I just have this const string, so it basically renames everything to a string. I don't have that everywhere, but I have it in most places, just because it's easier and quicker to write, and you know what it is. It's a string, you know, const slice const U8 is kind of weird to write, and anyway, not really in the style guide, but I don't really care. Then, so yeah, basically it just returns converted code at the end. It doesn't print it, it returns it, and then if we're printing the output, we just print it there. If we're not printing the output, we output it to file. Build directory, cm.build. So yeah, we create a folder. We create, if it's not there, we create this folder. If it's not there, which it is there now, we create this folder, we make the path, and then we write basically all of that into main.go. And we create a file called main.go in there. And then we create the Go module. Basically, we're just writing to files. That's all we're doing. What does this return? Okay, I should write that then. I just don't like inferred types. I really just don't like it. This is also a const U8 slice, isn't it? So I'm going to make this a string. I'll have to run this to see if it actually works after this. And the Go file path again is probably a string. That's a U8. Right. And you see I don't like inferred types, so I have to have child here. Just anyway. Child is actually it's at the top. It's child is at std.process.child, which is this struct. I don't even see this struct. Is it just the whole thing? Okay, it's the whole thing. Okay, all right. The whole file is actually a struct apparently, which I think is how Zig works. Everything you import is a struct. Anyway, that's it really. We're just basically just writing it to file, then running it. And then I guess, yeah, this is go run main.go. So this is the run command. Var child init go run main dot arena dot allocator cdo build directory dot inherit. I don't really understand this, to be honest. I think this is just telling the console to run the command. I think is what it's doing. I couldn't explain it at all. I don't know what .inherit means. I don't know what any of this stuff means. I just know that it works. And there was also one other thing that was really weird. Because we have the console commands, not console, I guess like the console colors. It doesn't work when you use the exe. So I'll show you, for example, what happens if on main we have this enable window ANSI colors. If I comment this out, see here now. So when you don't have this enabled, it does this nonsense. It basically prints it out the code and doesn't actually, because you can't read this. What's this? What's this? So for some reason, I have to have this enable Windows ANSI color, which I think is only, so if it's not Windows, you don't care. But if it is Windows, we get this const Windows enable virtual terminal processing with this code. Load of nonsense, basically. I don't know. We basically have to tell Windows to enable the colors. And I'm not going to pretend I can understand any of this code, but it tells Windows to basically print out the colors as code. Because now if we run this again, Zig build. If we run this again, now it works. See, it gives you the colors like that. Because otherwise it printed out nonsense. So let's put the semicolon back. Because the last thing you want is to look at it and see, well, what is this? You know, what's this? What? Nonsense. Anyway, it gets quite a few things. So most things work. I mean, switch statements. Switch statements were the worst thing. Oh my god. It's like switch statements, you think they're simple. I'll show you some switch statements. So wait, I've got to output the file to false. Then we can actually print. Then we can go to, say, we're going to show the AST nodes as well. True. Alright. So we have this switch that basically our syntax is almost identical to Go. Where even are we? Oh, we don't have the output code. Let's put the output code. Or the input code, sorry. Right. So the input code is this. Switch looks almost exactly the same as Go, really. So we just have case, colon, this with a semicolon. That's it really. Other than that, it's exactly the same as the Go syntax, really. Which wasn't. It's just I didn't really, because in theory you could have something like the Zig syntax, which I find pretty weird, because the Zig syntax is like, say, switch thing, whatever it is. This doesn't have multi-line comment, but it's basically Zig would be like, I don't know, say 0 and then this, and you can have a comma, or you can have the closed brackets, the open brackets, and then you have a comma. That's quite harder to parse than just having, because here you have the keyword case. You have the keyword case, so it's kind of easier. You know exactly when the next case starts. It says case. Well, I guess you could look for a comma, but it's just easier to parse, basically. I chose the easiest route. It's easier to parse this, and then the comma, and then you look for a case, and then look for default, or you look for case. It's a lot easier to parse. Anyway, but you think this looks pretty simple, right? Just that. It looks pretty simple. If I show you the AST, it's like, what the hell is this? So we have the switch statement with the switch. Then we have the identifier, which is on the left. And on the right is the switch body. And then we have children are the switch cases. And inside the switch cases, we have the literal, which is the condition. And this could be anything. I mean, it could be, for example, you could have, let's say you import a load of structs, right? Say you import some like library somewhere, whatever. Say case. It could be, It could be something like file.thing.thing.thing.value. Like that. That's what it could be. So you're going to nest it forever, basically, because it potentially could nest forever. Or it could be, for example, it could be this, and then that could be dereferenced like this, and then you could have this value as well. It's like it nests forever, basically. So you've got to account for that, and you've got to have this nest forever. But here we just have one, obviously. But it could, in theory, nest forever. So you've got to print the expression, whatever. And then on the right, you have the switch body, because these could have multiple things. They could have get off. They could have print. You could have print line something, and then print line something, and then for loop, and then print line, then for loop, and print line, then if statement, and they could go on forever. You could have an if statement in here, like this. You could have an if statement in here, and then we have another case or whatever. So you got to basically, it could go on for ages, and you don't know what's in here. So we got the switch body, and then inside the switch body we have the children, which is just print line 0 in this situation, but it could go on forever. And then we got that for every one of these. So basically that's it. But just doing all that is just such a pain. If I show you the code, like for parsing this, get off, be formatting, parse, we want switch. So we want fill switch body. Not that one. We want actually the process switch. All right. So we process the switch. We create the node. So it's a switch statement. We set the token to that. We increment to get past the token. I think the first token will be basically what the condition is. And I think even here this will fail. I think. Maybe not. No, it won't. It won't. I'm being wrong. I'm wrong. This is just saying save switch as the first token. Then we're looking for a left parentheses. And then we fill the switch condition, because this could nest forever. Not forever, but it could nest like 10 deep if you wanted it to. So we have to fill the switch condition, which basically will... for here, we're just presuming it's an identifier, which will fail if we give it an advanced condition. I've just done that just for simplicity, because I wanted to get it to work. I'll probably have to finish it later and nest them. Otherwise, this will completely fail if we put, a struct member. It definitely will fail. I will show you that failing right now. So if we create another one, and let's say, I'll just create a thing.value equals 0. And then instead of value, we're going to go thing.value. And we're going to make this 2. And then we're going to watch this fail because I haven't done this correctly. That's why it wouldn't give me an error. Alright, so we run this. And it gives you an error. It's expecting a bracket afterwards because I haven't coded this correctly. What it needs to do is some kind of it needs to nest basically until it finds. It needs to loop. This is because I just wanted to get it to work. Like, just work, please. Basically, I was just trying to get it to work. I have to do that later because obviously it can't handle advanced situations, which is kind of the whole problem with this. It has to handle nesting, which is always the problem because it could nest for like 10 deep. So I'll have to fix that later. So that's a problem I have to fix. But anyway, again, this is it's so complicated. I have so many functions, right? So there. So where are they? Again, no, get off. Okay, no, not this, not this. Okay, this one is what I'm on. I have so many because switches are so complicated. I have like 6 functions. All right. So fill the switch condition. Afterwards, we expect the right parentheses. We increment again. We expect the left brace, and then we increment again. This expect is actually very useful. It saves you a lot of writing because you've got to get the token, and then you've got to anyway. Because what expect does, I believe it just gets the token and then sees if the token is that, and if it isn't, then it puts in the error message that you wrote. That's how it works. And then we have fill the switch condition. And then we have fill the switch body. We fill the switch body, which is the complicated one. So we are, I was doing that for debugging. It doesn't work and useless now. We create the node, we call the switch body, we init the capacity of the child nodes because they are child nodes, and then we see what it is. So if is it a case, is it a right brace, is it a default? If it's a right brace, we break, which breaks the while loop. Then, for example, we append the child. I don't even remember most of this code. We fill the case block if it is a case, which again could nest forever. I should probably put the nesting, this kind of, I need like this, a while loop is what I need inside the condition. But I'll do that later when I can be bothered. Anyway, yeah, so you've got to fill this because it could nest forever. And then I'm actually confused. Try fill case condition. Actually, I'm very confused about this. Fill the case block. What does this even do? I'm confused. If it's a case... okay, we do everything together. So we fill the case... like we fill everything in this, and we fill the default block is very similar, except we don't have the condition with the default block. So basically... I didn't want to do that. What the hell is that? So we're basically filling everything. So we're getting the condition with the colon. Then we're filling the body as well. So if it's body, we fill that. Anyway, this is really complicated. Really, really complicated. And all this just to have a switch statement, and you think, oh, that's kind of simple, isn't it? It's not. It's really not. It's really not simple at all. And I still have to fix that. So you'd think that things are really simple. And again, this is going off the screen and going to drive me crazy because it keeps going off the screen. So yeah, basically it just converts this, which looks the same actually. The only difference between this and Go is that it has fmt.println and doesn't have brackets. Otherwise, it's basically the same syntax. Anyway, that's switches, and it was a nightmare to do. I'm not sure if there's anything else I'm forgetting. There might be loads of stuff I'm forgetting. Arrays, for example, I made arrays into slices. So I'll just show you arrays quickly. Alright, so array basically will convert it into a slice. Because if we put an array into a function, say array 3, I'm not even sure what array 3 does. So instead of using I use this like a while loop instead of a for loop. It works exactly the same though. That's basically what a for loop does. So yeah, this is basically just showing as using getting the index, which has this. We should have the array declaration and then array assignment, array access. You have the array access array, which will put brackets and put that into brackets, right? And then we plus equals 1 to that. That's how that works. I was just basically just testing the array access. And if you put this into a function, it would basically make it a slice. Anyway, so there's slices. So in theory, what I could do, it's kind of cheating. But say, for example, I do something like this. Get rid of that. And let's put here. Make this... I do actually have a way of getting the length. But it's kind of cheating again, because it's not actually built into the language. What we could do is we go int length equals len array. And this will actually work because it uses Go syntax. And then we can put here length. And then we could here go array equals append array and then put in 6. I don't know if that's going to work, but let's test it out. Because this is basically just Go syntax. It's not good Go syntax, but it's Go syntax. Because we're converting to Go, it will actually probably work. And it did work. It didn't question it at all. It just converted the function over because it's just a function call. And this will actually work. So if we copy this over to Go, about that, it works. So that actually did just work, which is kind of weird. But I don't like the Go syntax of append. Array equals append array. I don't like that. I would probably... My preferred syntax would be something like... Say, in theory, arrays should be different to lists. They should be, really. So I'd probably have something like... It would be list... whatever the type would be. I don't know if it would be like this. List int, whatever. Number list. That would be my preferred syntax. Equals 1, 2, 3, 4, 5. And then you do something like number list dot append. And then put 6. That would be my preferred syntax. But anyway, the Go syntax I don't like, to be honest, just because you have to repeat the same thing. So if you have number list, it'd be number list equals append, and then you can say number list again, which I just find this annoying to do without the same. Anyway, but it does actually work, and the length works because it basically sees it as a function call, right? It sees len as a function call. Oh, it's a function call. Okay, I'll print it as a function call, and it just works innately. So you can just get the length. Anyway, so you can kind of cheat that way and actually have append work like that, but it's, you know, it's kind of, it wouldn't work if you converted it to LLVM, for example. It wouldn't work. But I've obviously got to like have these as inbuilt functions, so I'd have to have it as like a registered token. Like print line, for example, is a registered token. If I show you show tokens true, see build run, show the tokens. So if you show the tokens, for example, if you look for print line, it recognizes it as dot print line, doesn't recognize it as a function call or identifier. Whereas len is identified as an identifier. So it's not an inbuilt function, which I should make it an inbuilt function if I'm going to use it that way. But I don't even know what syntax I want, because in theory you should have, because there's different, I mean, it depends what syntax you want, because Zig uses .len, for example. If it's like an array list, or if it's an array, say you do, I don't know, whatever. Let's do this, int array equals something, I don't care. You'd say int length equals array.len. That's the Zig way to do it. Or you could use the Go way of doing it, which is len array, like that. Which is better? It's your choice, really. It doesn't really matter. You gotta just, I think len would probably be the easiest one to actually make work, because here you have the array first, so it could be an array access. It could be, you know, it could be anything. It could be like a complete array copy. Anyway, it just depends what you prefer. Anyway, so that's kind of where I am now. It's mostly working as a language. The thing is, some things obviously I need to fix, like the switch statements won't work if I give it something advanced. But obviously I could try building something and see what's broken. That's generally the way you test things. Is you have a language, you test it, see what works, see what doesn't work. I think the main problem you'll have is so another problem would be like having different files. How would I do that? There's that to work out. Because obviously I would have to get all the files in the current directory, and then also I need to put it on the path, which isn't that hard really. Just a bit too lazy to do that, because here you could basically just do dot backslash and then .exe and then put in them, so you don't actually need to put it on the path really. It just means you'd have to put everything in this folder, which isn't really practical, which is why you put things on the path anyway. Also, it should be in release mode, because it's in debug mode. That's quite a big exe file. Make it release safe probably would be the easiest thing, the best thing to do. Not release fast or release. Anyway, it doesn't matter. It's not exactly slow, is it? At this point, I think that's basically it, really. So obviously, I need to work out having different files. Like, how do I do that? The easiest thing to do with different files is just to paste them. Just paste them into one big file would be the easiest thing to do. Then there's things like, well, for example, I'll give you an example. If I just put in, so if I don't use print line, for example, just get rid of print line entirely, comment it out. I don't even know if what this will print out. And say if I run this. Okay, wait. The problem is every time I run this, it will, okay, output a file true. Show AST nodes false. Show input code false. And save that. And then do this. Zig build. I should output it. Then what I really should do is I have a separate folder for this. Run it again. It gives you an error. I don't know if it's type. Okay, that doesn't recognize comments. Okay, I'll just delete it then. Oh, obviously, I need to work on comments, because that should recognize that as a comment, not as. Anyway, let's do this again. It should give you Okay, it didn't run anything now. I thought this would give you an error. I mean, because there's a print line here. Maybe if I get rid of this. Get rid of this. These will not... Okay, I'm just going to get rid of everything. Just leave me alone, please, because it's going to say you're not using it. Ooh, you're not using it. See, here, we got FMT and we're not using it. That's another problem with Go. Do I have to just have a random print line with nothing? Otherwise, it's like I need to detect if there's a print line. If there isn't a print line, then I need to... This is just a nightmare, really. Like, I have to detect if I have a print line and I'm using FMT. If I'm not using FMT, I need to not import it. And it's just like, why? Why? It just like, it just drives me crazy, that. But in most situations, I'm going to use print line because it's a console app. But maybe I don't use it in some files. So I import it when I don't need to import it. And it's a nightmare. And you have this problem. Anyway. Still a few things to work out. But it generally just works now. And I have a programming language. So I can, do this. Print line. Number. And then it converts and runs. And it prints out 10. And then I can put in number equals this. I mean, one thing I probably should have is printf, because printf would be very useful. Because the problem with this is if I put, let's say I do this, string output equals hello. And I want to put some, let's say output equals this. And I want to put this output. And then this. There'll be gaps in between them because that's how Go works. They will insert the spaces for you because you need a space, right? No, I don't want a space. I don't want a space between them. Why did you put a space in between them? That's what Go does. So you got to have printf just to tell it not to put a bloody space in between because it's annoying. It puts a space in for you, which you don't want all the time. Anyway, these are the quirks of Go which do annoy me sometimes. Anyway, so yeah, that's as far as I've got. I'm not sure what I'll do next. I have no idea. Of course, the long term I need to convert to LLVM, but to convert to LLVM I basically need to do all of this checking, and I need to actually track things. I need to track local variables, I need to track all the types of everything, I need to track compatibility. Also, one thing my programming language doesn't do at all is track the names. So I could do something like, I'll just give you an example. So here, this should give you an error because we have an undeclared thing. What's thing? Does it exist? We don't know. We haven't checked it. We don't check for anything. I put in error sample.error 4.error 4, and then turn this off. We will get an error. Or we won't actually get an error. It will just output it. But this will give you an error in Go. It doesn't exist. If I copy this into Go, it will give you an error. What's thing? Where'd you get it? Where'd you get it from? We haven't tracked anything. This is the problem. So obviously we need to track things and make sure they exist before using them. But that's also a headache because something could be an inbuilt function. Anyway, I've got a few things to do. It's not quite done yet, but we made a lot of progress. So thanks for watching. I'll see you guys next time.